Hey, I didn't see you come in. Welcome to Starkey's Corner.
In today's episode, we're going to talk about Standard 3B, identifying the rate of change. So, here's our work problem for today. Mr. Haas weighed 330 pounds in March of 2018. He currently weighs 240 pounds. Assuming he lost weight at a constant rate, what is the rate of change? So first, we need to identify the independent and dependent variables. Our independent variable, or x, we know is always time. In this case, months. Our dependent variable is the other thing we're talking about, which in this case would be the number of pounds. As we all know, rate of change can be found using our slope formula. M equals y2 minus y1 over x2 minus x1. Simply identify the number of pounds. So we start with 330 minus 240 over. Our months are going to be a little bit hard to identify. So March of 2018 was 13 months ago. So currently would be 0. So all we have to do is simplify this. And we get 90 pounds for 13 months.
And if we simplify this, we get roughly 6.9 pounds per 1 month. And today we have a guest visiting us in Starkey's Corner.
Hey everyone, I'm your special guest, and we're back on Standard 3B with a brand new great problem about our very best friend, Mr. Starkweather. So Mr. Starkweather had one gray hair before he left for Easter weekend, 3 days ago. Now, 1 hour ago, he had 143, and I know because I checked his scruffy head. Now, we want to know what is the average rate of change. So what we have to do is identify some variables. We have two things going on here. We have time, and we have hairs. So if I look at my time, be my x value. The problem is I have it in terms of days and hours, so I'm not sure what I want to get that narrowed down to yet. We'll see what's easiest. And then if I look at my other variable, the dependent variable, my y, that would be how many hairs on his little bitty head. And so this would be the number of hairs that are no longer orange like this marker. So they're turning gray. So let's look at finding the rate. Again, you have a slope formula where we can look at y2 minus y1 over x2 minus x1. You might ask yourself, why? Because we want to know how many hairs this guy has that are gray. So let's start with what he had an hour ago. Starkweather had 143. Before the weekend, he had 1. So there's my change in the y values. Now, time-wise, we go from an hour ago to 3 days. So it's probably easiest to go, 3 days equals how many hours? 1 day equals 24 hours. So if I triple that, that gives me the magic number of 72. So if I have 72 hours ago versus an hour ago, I can find my rate of change. We do a little math. This turns into 142 all over 71, which simplifies to 2. But now the important question is he getting 2 gray hairs a minute? Or an hour? Or a day? Or is it how many days or minutes or hours he gets a gray hair? So you gotta think, what was our y values? It was the hairs. So it's 2 gray hairs for every, in terms of time, we put this into hours, so 2 gray hairs, which is misspelled for a second until I fix it and add the R. And there you have Starkey's rate of gray hair change.